Hi, I'm Selena, a teacher with 20 years of experience and a test prep expert with Study.com. Today we're going to focus on the FTCE Physics K-12 032 exam, Knowledge of Electricity and Magnetism. In this series, we'll break down key concepts like circuits, electric fields, and magnetism, so you can feel confident and ready on test day. Let's get started. If the electrical field between 2 points is zero, what does this suggest about the potential difference between the 2 points? A, it is also zero. B, it is positive. C, it is negative. D, it cannot be determined. Let's do a process of elimination. B, a positive potential difference needs a non-zero electric field. C, a negative difference also requires an electric field. D, it can be determined if the field is zero, the potential difference is zero. The correct answer is A. It is also zero. If the electric field strength between 2 points is zero, then the potential difference between the 2 points will also be zero, as per the formula V equals ED. Since the electric field between E is zero, no matter the distance D, the product will be zero, meaning there is no potential difference between the 2 points. What is the unit of resistivity in the International System of Units? A, farad meter, B, ohm meter, C, voltmeter, or D, coulomb meter. Let's eliminate the wrong answers. A, farads measure capacitance, not resistance. C, voltmeter is a tool, not a unit. D, coulombs measure electric charge, not resistivity. The correct answer is B. The SI unit for resistivity is the ohm meter. Resistivity is a measure of the material's ability to resist the flow of an electric current. It is calculated as the resistance of a cube of the material measuring 1 meter on each side. If a resistor with a resistance of 4 ohms has a current of 3 amperes flowing through it, what is the voltage across the resistor? A, 12 volts, B, 30 volts, C, 24 volts, or D, 7 volts. Let's do the process of elimination. B, 30 volts would come from 10 amps, not 3. C, 24 volts would require 6 amps. D, 7 volts doesn't match any correct I times R combo here. The correct answer is A, 12 volts. According to Ohm's law, voltage is equal to current multiplied by resistance. So in this case, the voltage would be 3 amperes multiplied by 4 ohms, which equals 12 volts. This represents the electric potential difference across the resistor. What is the direction of the electric field just outside a charged conductor? A, the field does not exist outside the conductor. B, parallel to the surface of the conductor. C, perpendicular to the surface of the conductor. Or D, the direction depends on the shape of the conductor. Let's look at the wrong answers first. A, the electric field does exist just outside a charged conductor. B, the field is not parallel, it points straight out. D, the shape may affect strength, but not the fact that the field is perpendicular. The correct answer is C. The electric field just outside a charged conductor is always perpendicular to the surface. This is a direct result of Gauss's law. The electric field lines are perpendicular to the surface because the charges on the surface of the conductor repel each other and want to be as far apart as possible, which results in a field that is perpendicular to the surface. Thank you for joining me on some practice questions on the FTCE Physics 6-12 032 exam. Knowledge of Electricity and Magnetism. For more practice, check out our FTCE Physics 6-12 032 playlist. And for even more detailed practice, strategies, and customizable study materials, head over to Study.com and check out our FTCE Physics 6-12 test prep course. Those who use Study.com boast a 92% pass rate. Our courses include full-length exams, hundreds of authentic practice questions, and short, targeted video lessons, specifically developed based on the latest test updates. With our resources, you'll know exactly what to expect on test day. Like this video and subscribe to this channel to get all the latest FTCE test updates. And please leave your questions and success stories in the comments. We would love to hear from you. Thanks for watching and happy studying.